Intermediate Algebra Mid-Course Assessment Questions 10, 11, 12, and 13. The instructions over question number 10 just read multiply. Question 10 has a -2 p to the third power times r being multiplied to 3 p to the second power times q times r to the third power being multiplied to -3 q to the third power r to the third power. So let's start by combining the constants together. We have a -2 times a -3, or -2 times a 3 times a -3. So we have down here, I've copied those down, -2, +3 times -3. This makes an 18. Now we can combine together our variables. We have 3 variables from the first term for p, so p to the third power. For p in the second term, we have p to the second. And then for the p's in the third term, we have none represented. So we have p to the third, p to the second. When we're multiplying together variables, we sum together their exponents. So we end up with a 3 plus a 2 to make a p to the fifth power. With the q's, in the first term there are no q's to give, but in the second term there's 1 q, so we'll copy that down here. And then in the third term we have 3 q's available, or 3 q's available. Now that 1 q, it has to the first degree. It has a 1 here even though we don't see it. So this is a 1 plus a 3 to make q to the fourth power. Then for the r's, we get a single r from the first one, we get 3 r's from the second one, and we get 3 r's from the third one. So this comes out as 1 plus 3 plus 3 to make 7, so r to the 7th power. Moving on to question number 11. The instructions read, multiply and write the answer in scientific notation. So we have 6 times 10 to the 5th power and 8 times 10 to the 8th power. So we're going to look at the constants first, the 6 and the 8. 6 times 8 to get a 48. Then we copy down the times 10. Treat the 10, the base 10, just like it was a variable, and copy it down, and sum together the exponents. So I have a 5 plus an 8 to make a 13. So I have a 48 times 10 to the 13th power. However, in scientific notation, our starting number needs to be between a 1 and 10. However, it cannot be equal to 10. So to create a number that's between 1 and 10, I need to move the decimal point behind the 48 back 1 place so that it makes a 4.8. Because I've moved the decimal place, however, 1 to the left, I need to sum a 1 onto that 13. So now it's 4.8 times 10 to the 14th. Let's move on to question number 12. Question number 12's instructions read, simplify. I have a -0.6 r to the second power, s to the 9th, t to the third, overall raised to the second power. When I have some exponent to the outside overall raised to the others, I need to pull it in and multiply it to the exponents inside. So I'm going to take this 3 and I'm going to multiply it to the first, which is on that 0.6. So this creates a 1 times 2 to make a 2. So I'm taking the -0.6 to the second power. Now this is going to be a -0.6 times a -0.6. Then I'm going to bring that 2 and bring it in on the 2 on the r. So 2 times 2. I'm also going to put that 2 on the 9. So 2 times 9. And then bring it in on the 3. So I get 3 times 2. Now let's finish this up. So I have a -0.6 times a -0.6, which makes a 0.36. For the r, I have the 2 times 2, so this makes r to the 4th power. For the s, I have a 9 times 2, which makes s to the 18th power. And then for the t, I have a 3 times a 2 to make t to the 6th power. Moving on to question number 13. The instructions read, factor completely. If prime, so state. So I have an x to the 4th power minus a 16. Well, when I look at this, I can square 16, so I look to see if I can square the x to the 4th power as well. I can. X to the 2nd overall raised to the 2nd power. That's x to the 4th. Just like in the previous question, if I pulled that 2 back in on this, it would make x to the 4th power. I can square the 16. 4 times 4 makes a 16. That means that I have a difference of squares. So according to my rules, I can rewrite the bases as the conjugates, a plus b times a minus b. So in the a position, I have an x squared, so I write an x squared plus a 4, and then an x squared minus a 4. However, when I look at the x squared minus 4, I can see that this is a difference of squares a second time, because the x is already squared, and the 4 I can take to a 2 to the 2nd power, so I can square it as well. So I'm going to take the conjugates of the bases of the second difference of squares. The x squared plus 4, I can't do anything with this. I don't have any rules. There's nothing I can actually do with it. It's as factored as far as it's going to get. So I take the bases of that second binomial, and I get an x minus 2 and an x plus 2. Now it's factored completely.